The second example, determine the diameter of the pipe AB, BC, CD in the 27-acre drainage basin shown in the figure. Area, runoff coefficient, and inlet time for each subcatchment is shown in the table. The length and slope for the each pipe in the column 2 and 3 in the table. Next table as well show use the same runoff rainfall intensity equation from previous example and assuming n equal to same 0.015. Okay, the same method was illustrated in the previous example is used for each pipe, except now the time of concentration must be include both inlet time and flow time through the upstream sewer. Result obtained from the previous example is shown in this table. Okay, we move to the first pipe AB. This pipe drain, we can look at the figure. For pipe AB from here to here, is drain receive the runoff from the catchment 1 and 2. Okay, so for the subcatchment 1 is 2 acre and runoff coefficient is 0.7. Subcatchment 2 is 3 acre and C is 0.7. And for the inlet time for subcatchment 1 is 5 minutes, and subcatchment 2 is 7 minutes for inlet time. So we can choose the time concentration for pipe AB is 7 minutes. Okay. So in this case, we find the summation of CA, C1A1 times C2 plus C2A2. So we got 3.5. And time concentration, we use 7 minutes. Okay, it's the larger of the two inlet time. Calculation for the required diameter was carried out in the same way as the previous example, and result was shown in the second row in this table. And calculated diameter is 1.94 and round up to 2 feet. Okay, for pipe AB. So this result is shown in the second row. Okay, for pipe AB, 2 feet, and the flow time is 1.76. Okay. And the next for pipe BC. Pipe BC is a drain from subcatchment 1 to subcatchment 5. You can look at this. For pipe BC, it's drain from 1, 2, 3, 4, 5. Okay. And next we check the time concentration. Okay, let's see for this from pipe 2, 3, and 4. Okay, so we check the time concentration from pipe 3 is already is 4, is 10 minutes. Okay, but the flow time is 1.75 flow time from the pipe flow, and for 4 is the 10 minutes. Okay, and for 5 is the 50 minutes. Okay, that is the flow time, the time concentration from different parts. So we can check which one is the largest time. The first time is from 10 plus the flow time in the pipe, and the second is 7 plus on this. So we can check that flow time is 1.76. Okay, so this is another way, 1.76. Okay, and 10 from catchment 4 and 15 from catchment 5. So we can choose that the maximum is 15. So we choose that the time concentration for the pipe BC is 15. Okay, they say that the same as so we choose the time concentration for pipe BC is 50 minutes. I already showed in the calculation, and we check the summation of CAs. That is from 1 2, adding another 3 area, so we got a summation of the CA is about 10.8, and diameter is 2.87, round up to 3 feet or 36 inch for pipe BC, and put in the third row in this table. So we got 3 feet and flow time is 1.15. Okay, and pop the last one, the pipe CD. Okay, the pipe is drained from 7 subcatchment using the same method. Okay, we have to identify the time concentration for pipe CD. So we check the time concentration. The first rule is 15 plus we check that this is flow time is 1.15. So the first rule is 15 plus 1.15, and this check from direct flow from the sub area. So we got check from number 6 is 15, number 7 is 15. Okay, so we have 15 and 15. You can choose the maximum is 16.15. That is the maximum, the time concentration. So we choose the TC is 16.2. Summation of area is put together is 15.3, and the diameter of the pipe 3.2 to round up to 3.5. Okay, and put in the fourth row in the table. Okay, so finally we have the required diameter for pipe ABCD is for 21, 36, and 42 inch respectively, and we can convert to meter if you want to apply in a catalog in Thailand. Okay.